making panic to allow each and every member in the meeting. So next time onwards, everybody followed strictly the college ID only. Okay, so I will share my screen so that you can get the idea how many people are there for sending the request again and again. Okay, so to start with today's lecture, we will somehow discuss about the syllabus that we are having for this year. So, uh, this is the structure, and I am dealing with your subject distributed system. So, uh, it will be having 30 marks for your ISC and ESC of 70 marks, as well as it is having lab, but I don't know what is the future. So, for lab or your term work, we are having 25 marks. So, this 125 total weightage of this subject is 125 marks. Okay. So don't go for lecture hours or so, LTP. Already, as per the instructions from the authority, I have decided we will be having 4 hours per week for each and every subject. You might have gone through the timetable as well. Akanksha, your mic is on. Akanksha Patil.
Yes, ma'am. Yes, ma'am.
Do you have any? Okay, okay. Thank you. So, daily schedule is of 4 hours. So, two subjects you are dealing with each day. Okay, and then after I think 3 o'clock onwards, you will be having your own time. So, yesterday only we got one mail for your. Just a second. I think this mail is not shared with you people. Internship, related to internship, the mail was there from Jadhav madam yesterday. Um, yeah. And I think on LinkedIn, I saw Ashutosh's profile in which he already shared that he is having internship with Internshala, something. Okay, so these are the topics or the trainings available with Internshala. So these type of things also you have to do in your um, after 3 o'clock or the time that you are having after this 4 hours session. Okay, so concentrate on this also. This will be shared by madam also once again. Um, okay, so to deal with as as per the tradition, we are starting our lecture with the syllabus and all these things. So I will just brief you with the syllabus. Okay. So distributed system, already we have discussed the examination scheme. No need to go for course outcome and all those things for this online lecture. So you are so lucky for this. So in this section one, we are having the topic fundamentals, in which we are dealing with the fundamentals of operating system, what is distributed system, then evolution of it, then some models related to distributed computing system, then why distributed system is gaining popularity, then some issues in designing the distributed system, then its computing environment and some of the protocols for distributed system like flip and vmtp. So this is the first unit we are having. Then second is message passing, in which introduction, each and every topic is having its own introduction, no matter. So then message passing in this desirable features of good message passing system, issues in IPC by message passing, then synchronization, buffering, multi-datagram messages, encoding and decoding of message data, process addressing, failure handling, group communication, and we are having the case study of RMI and Corba that is included in this chapter, message passing. Then we are having remote procedure calls. So again, introduction, then RPC model, then transparency of RPC, implementation of RPC mechanism, stub generation, RPC messages, marshalling argument and results, then server management, parameter passing, call semantics, communication protocols for RPC, then client server binding, exception handling, security. These all things will be covered in RPC. And then synchronization in distributed system. So in this introduction, process migration, threads, clock synchronization, event ordering, mutual exclusion, deadlock, election algorithm, and then issues in designing distributed system and role of middleware in distributed system. This will be covered. These four topics are there for section 1. And then for section 2, we are having distributed mutual exclusion. In this again, introduction, classification of mutual exclusion algorithms, preliminaries, then a simple solution to distributed mutual exclusion, non-token based algorithms, Lampert's algorithm, Ricard Agrawala algorithm, token based algorithm, Suzuki Kasame's broadcast algorithm. These things are there. Then we are having distributed deadlock detection. So in this again introduction, preliminaries, deadlock handling strategies in distributed system, issues in deadlock detection and resolution, control organization for distributed deadlock detection, centralized deadlock detection algorithm. Okay. Sorry for interrupt. Then centralized deadlock detection algorithm, distributed deadlock detection algorithm, avoidance and prevention algorithm, hierarchical deadlock detection algorithm. These algorithms we are going to study in this deadlock detection topic. Then distributed file systems. In this distributed resource management, concepts of file system, distributed file systems in which we are again dealing with for distributed file system. We are dealing with the introduction, architecture, mechanism for building distributed file system, design issues, then log structured file system, case study. Here we are going to study the Google file system as a case study. And then finally the distributed shared memory. In this introduction, architecture and motivation, algorithms for implementing distributed shared memory, memory coherence, coherence protocol, design issues, and here we are again studying or we are dealing with the case study of Linda. So these are the 8 topics that we are going to cover in distributed systems. So preferably the book is Distributed Operating System Design. That is by P.K. Sinha. I think it is not properly viewable. Okay, no problem. Book by P.K. Sinha for Distributed Operating System, that is there for unit number 1, 2, 3, 4. And Advanced Concepts in Operating System by Mukesh Singhal and N.G. Shivaratri. This book is there for the remaining topics, that is from second section 5, 6, 7, 8. Okay, and for case studies you can go through Google or anything. As per the syllabus structure, here distributed computing by Sunita Mahajan, Seema Shah from Oxford University Press. They are referring the book, but no matter. We can go through anything. Preferably P.K. Sinha you should go with. Okay, so this is all the syllabus structure for this semester we are having. So we will directly go for our first topic. Okay, that is fundamentals. Till now, everyone is clear with the subject? Whenever you will be having any kind of problem during the lecture, you can send your queries in the chat window. Okay. So we will start with our first unit, that is fundamentals. Okay. So as per the syllabus, we are covering here the fundamentals of operating system. What exactly is the distributed system? Then evolution of distributed computing system. Then distributed computing system models. Distributed computing gaining popularity. Why the distributed systems are getting popular right now or nowadays? So that will be covered over there. Then issues in designing distributed system. So suppose for example some kind of problems are there, so those will be discussed in this bit. Then introduction to distributed computing environment and protocols for distributed systems, that is FLIP and VMTP. So for this, the objectives for this chapter are, at the end of this, not video, but the chapter, you will be able to describe the basics of distributed systems and describe the different distributed computing system models. Okay. So to start with, we are having the structure of operating system. So what we mean by an operating system? It is a collection of software that manages um, computer hardware resources and provides common services for computer programs. So if we go through the structure of operating system, you already have studied the subject operating system matter. So where it exists exactly? So here is the user, then your applications are there, and then after to deal with the hardware part of your computer, you absolutely need the operating system, without which you cannot go for doing whatever task that you want to do. Okay, so here is the existence of your operating system. So if we consider for the functions of operating system, what are the different functions of operating system? So that are listed over here. First of all, the security. Security for securing your data present on your system, or some kind of softwares are there, then databases are there. So to secure all these things, all your valuable data, you need operating system by which you are providing different algorithm. You are providing different algorithms or some checks to give the authority to a particular user only. So all these tasks will be done by your operating system. So security, definitely it is the valuable function for OS. Then control over the system performance. System performance, like how your system is going to perform, means how your CPU is utilizing. Rather, we can have the facility of task manager where we are looking into the performance of your system, which different applications are running on your system, right? And so to deal with all these things, which applications are means consuming more and more memory, or these things we can find by using your operating system. So by which you can have the control on the system performance. Then comes job accounting. So different algorithms you might have studied previously. So which particular application you should give uh, maximum priority, how to deal with that particular job. So job accounting, or like first come first serve, or priority based. So these algorithms we have already studied. So according to which we are giving priority to the particular operations. So this task is also done by operating system. Then error detection aids. So these are also the facility provided by operating system. How? So at each and every um, application or each and every program, we are having the facility of troubleshooting, right? So this kind of troubleshooting facility, whenever you are going to insert any new hardware, okay, or if your software part is not working well, so how you are going to troubleshoot all the problems? So the proper solution will be given by the operating system with its inbuilt solutions only, right? So suppose, for example, a primary example, like if you have not inserted the patch cord to your system, okay. So at that time, if you are trying to go for internet connectivity, so what will be the display on your screen? So your internet facility is not available, or this kind of error message will come, okay. So whenever you go for troubleshooting, on that particular icon which is present at the uh, uh, lower right corner, so over there you can find the things, mm, like you should insert the patch cord, or not exactly patch cord, but you should insert the just a second. Puneet joined or not? Okay, so at that time, the troubleshooter will give you the answers, like you should go for connecting the wire, or if for sometimes if your server is down, at that time he will say the message that your server is not working properly. Means what? These kind of solutions will be provided by your um, troubleshooters, which are inbuilt program for error detection aids. Okay. Then coming to the coordination between the software and user, definitely for software coordinating, the main task of operating system itself is coordination between users and softwares. Okay. So we can say that it is the DUA middleware present between the software and the user. Then again, memory management, how you are going to manage the memory. Okay, so memory management, process management, these are the tasks already covered in operating system. So all these are the functions of operating system. Then device management, whatever the different devices we are attaching with our system. So how we are going to deal with all these things, no matter your microphone, your speakers, then mouse, keyboard, all these devices, all these are managed properly. And finally, the file management. Okay, so for this file structure, you might have already gone through. So all these are the functions of operating system. But what exactly is the distributed system? So a distributed system is a piece of software that ensures that collection of independent computers appears to its users as a single coherent system. Okay, so in this we are dealing with different n number of computers. Okay, and uh, that all computers are appearing to a particular user as a single coherent system. How? That we are going to see in the next slide. Then, for example, here we can take the example of World Wide Web, WWW, which is the biggest example of distributed system. And the others are intranet, which is a portion of the internet managed by an organization. Okay. So why we are taking the example of World Wide Web over here? So, suppose for example, we are going for searching some of the documents on Google, okay? But no matter, means suppose I'm fetching with one query, uh, okay, so latest news in Pandharpur, fine. So at that time, how the process will be done? So he or the search engine will fetch the query to a particular server which is having the data related to Pandharpur. Okay. So at that time we can say that means I'm unaware of on which particular server that all things are present. Okay. Maybe the server or the that server may be located in Mumbai. Okay. Or may be located in Delhi. So no matter wherever the server is, I am getting the data which is required for me. Okay. So that is why internet is coming as a best example for distributed system. Then again, if we consider for organization, okay, so at that time, uh, for organization, we are dealing with our FTP server, okay. So for FTP server, um, actually we know that FTP server is present at NKN location, okay, but if any new person comes or the people from second year or first year, if they try to access the FTP, they are getting the data for all, like for CSE department, mechanical department and all, okay. But if we ask them where is the exact location of that particular server, they will be unable to answer. But we know that the server location is at NKN, and from there the data will be given. At NCAN also, we can say that different machines will be there on which different data is kept, or departmental data is kept on different machines, no matter. Okay. So intranet also will be coming as a good example for distributed system. Then after this, computer architecture consisting of interconnected multiple processors are basically of two types. So here we are having two systems, we can say. The first one is tightly coupled system and second is loosely coupled system. The diagram itself is showing you the details. So how? So in case of tightly coupled system, here these CPUs are like your separate machines. Each and every machine is shown here as a CPU, and all these are having system-wide shared memory, which is having some interconnection hardware present over here. So in this way, your tightly coupled system will work. And here, the loosely coupled system is shown. Loosely coupled means what? Means what? Ki each and every machine is having its own CPU and its own local memory. Here in tightly coupled system, it is having system-wide shared memory. Means all the systems will be sharing one particular location as a shared memory. But here in case of loosely coupled, each and every machine will be having its own. Okay, and all these separate machines are connected by using this particular communication network. Okay, so this is the loosely coupled system. So if we say for example go in the details for this, so we can say that suppose in case of tightly coupled system, this particular system, say for example this is my system number A, okay. If he is saying that, say for example x, he is assigning one integer x as a value of 100, okay, then that 100 value will be seen by all other systems, right? Because it is having system wide shared memory. And if suppose this particular system, say for example C, if he changes the value of x to 200 from 100, okay, then now all the system will have the value of x as a 200 now. This is the case of tightly coupled system. But in case of loosely coupled system, if this particular machine is saying x is equal to 100 and this machine is saying x equal to 1, so that x equal to 100 will be local to this machine only, and x equal to 1 will be local to this machine only. Means they will be having their own independent memory. Okay, so they will be dealing with their own data over there. So that is why the name is loosely coupled system. So in short, we can say here that a distributed computing system is basically a collection of processors interconnected by a communication network in which each processor has its own local memory and other peripherals, and the communication between any two processors of the system takes place by message passing over the communication network. Okay, so how the message passing will be done? So here for this we are having different algorithms that we are going to study in the second chapter. But in that way, by message passing, each and every system will be communicating with each other. Then for a particular processor, its own resources are local, whereas the other processors and their resources are remote. So together, a processor and its resources are usually referred to as a node or site or machine of the distributed computing system. So here, each and every machine we are calling it as a node or site or a machine. So coming to the next bit, that is evolution of distributed system. Previously means before this particular syllabus, when like 4 5 years ago, one question was there on evolution of distributed system was also there. So in book, if you go through, it will be having around 2 page summary over there for evolution of distributed system. But since last 2 3 years, this kind of question is not yet asked. So you just keep in mind how the distributed systems are evolved. So within 1945 to 1985, the computers were large and expensive. As we know, the first computer or the supercomputer, we might have seen the photograph of it also. So they were absolutely large and expensive. Then again, no way to connect with them, and all systems were centralized system at that time. Means whatever the data was there, we are having at the central location only. Okay, so that way, in that particular period of time, the working was there. But in case of mid of 1980s, some powerful microprocessors were invented. Then high-speed computer networks like LANs and MANs were invented, and then after they were came into existence and they came into the use. And then after came the distributed system, which we are now using. Okay. Then why should we go for distributed system? So the availability of powerful yet cheap microprocessors like PCs and workstations. So for that purpose, we are going for distributed system, and again continuing advances in communication technology. One thing I forgot to tell at this particular point, the tightly coupled system and loosely coupled system. So any example for tightly coupled system, if you remember? And loosely coupled system. Yes, anybody having idea of tightly coupled systems example? Otherwise, I will pick anybody randomly. Yes, Amol is there. Amol Anuse. आहे का अमोल जागेवर? रोहित गोडसे. हॅलो. अरे बाबा एकदाच. Any example for tightly coupled system or loosely coupled system? आतापर्यंत काय सांगितलेलं थोडस तरी कळलेलं आहे असं म्हणायला हरकत नाही. बोला की. अमोल.
बोला मॅडम.
नुसता माईक ऑन करायला सांगितलेलं नाहीये. यू शुड आन्सर समथिंग. Otherwise, you can put your answers on chat window also. That will also be communicated. पोरं काय बोलेना झालेत, काय झाले कोणास ठाऊक. Okay, I will tell the example for this. So tightly coupled system. Um, Previously, I was using this example of like the exam or the example from the movie स्वदेश. ओके, स्वदेशमध्ये काय बघितलं होतं आपण की एक सॅटेलाइट लॉन्चिंगच्या टाइमला सगळ्या सिस्टीम वरती एक पर्टिक्युलर क्लॉक आपल्याला दिसत होता आणि जेव्हा ते काउंटडाऊन फ्रॉम 10, 9, 8, 7 अप टू 1 0 झालेलं आहे तर त्यावेळेला नॉट ॲट ऑल फ्रॅक्शन ऑफ सेकंड्स डिफरन्स इज देअर इन any of the machine, and at exactly at 0 that satellite is launching आफ्टर फायर. ओके, सो या एक्झाम्पल मध्ये आपण काय म्हणू शकतो की वॉट एव्हर द वर्क इज देअर दॅट इज डन बाय से फॉर एक्झाम्पल पर्सन ए, पर्सन बी, पर्सन सी, या सगळ्यांसाठी एक शेअर्ड मेमरी असणार आहे. त्या प्रत्येकाचं काम हे एका ठिकाणी एकत्र करून जे काही सॅटेलाइट लॉन्चिंगची जी तुमची प्रोसेस असणार आहे, इंडिव्हिज्युअल काम केलं ठीक आहे, पण नंतर सगळ्यांचं कोलॅबरेटिव्ह एकत्र आणून मग तुमचं एक्झॅक्ट रिझल्ट तुम्हाला या केसमध्ये मिळून जातो. ओके, सो आत्ताच्या ह्याच्यामध्ये आपण म्हणजे सॅटेलाइट लॉन्चिंग किंवा हे जे आहे ते आपण टाईटली कपल्ड सिस्टीमच्या अंडर घेऊ शकतो. आत्ताचा आपला मिशन मंगल पिक्चर मूवी सगळ्यांनी पाहिली असेलच डेफिनेटली. तर त्यामध्ये सुद्धा जी काही प्रोसेस आहे प्रत्येक जण काहीतरी काहीतरी त्याचं सेपरेट काम करतो. ठीक आहे, पण जेव्हा तुमचा एकदा फायनल प्रॉडक्ट बनत असतो तेव्हा सगळ्यांचं काम एकत्र आणून मग ते काउंटडाऊन तुमचा बिगिन होणे परत ते जे काही सॅटेलाइट लॉन्चिंग वगैरे आहे ते तुम्हाला त्या ठिकाणी बघायला मिळतं. सो वेन एव्हर यू आर फेसिंग दिस काइंड ऑफ प्रॉब्लेम्स लाईक collaborative work you have to do, so at that time you can say that tightly coupled systems are coming into existence. And again, loosely coupled system, if we see, then as the diagram itself is showing its example, like in our laboratories. ओके, आपली कुठलीही जर लॅब आपण बघितली तर प्रत्येक मशीन हे सेपरेटली वर्क करत आहे. एका मशीनवर एक पर्सन बसलाय, त्याचं एक वेगळं काहीतरी से फॉर एक्झाम्पल जावाचा प्रोग्राम चालू आहे, दुसरीकडे एक स्टुडंट बसलाय त्याचा काहीतरी एक पायथॉनचा प्रोग्राम चालू आहे वगैरे वगैरे. पण ऑल दे आर कनेक्टेड बाय युजिंग सम कम्युनिकेशन नेटवर्क. ओके, आणि त्या ठिकाणी एका लॅब पुरतं आपण बघतो की तिथे एक 24 पोर्टचा एक स्विच असतो. ते त्या स्विचला प्रत्येक इच अँड एव्हरी मशीन इज कनेक्टेड टू दॅट स्विच. अँड देन जर मशीन माझं कनेक्टेड असेल तर जर मला दुसऱ्या एखाद्या माझ्या फ्रेंडचा काहीतरी डेटा एखादा प्रोग्राम हवा असेल तर मी काय करते त्याला पिंग करते, त्याचं मशीन मला जर ॲक्सेसिबल होत असेल आणि त्यानं एखादा फोल्डर शेअर केला असेल तर त्याच्याकडून तो डेटा घेते वगैरे वगैरे. सो हे एक्झाम्पल किंवा लॅबोरेटरीचं जे काही स्ट्रक्चर आहे ते आपण लूजली कपल्ड सिस्टीमच्या अंडर कन्सिडर करणार आहोत. And for this लुजली कपल्ड सिस्टीम म्हणजे ओव्हरऑल लॅबचं जर स्ट्रक्चर तुम्ही डोळ्यासमोर ठेवलं तर पुढचा जो पार्ट आहे आपण बघणार आहोत तो लगेच लक्षात येत जाईल तुमच्या. ठीक आहे. सो हा वाला पार्ट आपला झाला होता वाय टू गो फॉर डिस्ट्रीब्युटेड सिस्टीम. अँड अगेन ओके, सो गेनिंग पॉप्युलॅरिटीमध्ये आपण त्याचे ॲडव्हान्टेजेस बघणार आहोत. सो हिअर द ॲडव्हान्टेजेस ऑफ डिस्ट्रीब्युटेड सिस्टीम्स ओव्हर centralized systems. So what are they? So first of all, absolutely the economics. Why? So a collection of microprocessors offer a better price performance ratio than the mainframes. So that is why the economically, if we consider the data, distributed systems are more and more feasible. Then again, they are reliable. If one machine crashes, the system as a whole can survive. Higher availability and improved reliability is the advantage of distributed system. रिलायबिलिटीच्या केसमध्ये सपोज फॉर एक्झाम्पल लॅबोरेटरीमध्ये एक 2-3 मशीन जरी खराब झाले असतील तरी ओव्हरऑल वर्किंगमध्ये काही हॅम्पर होतो का? ओव्हरऑल इन द सेन्स बाकीच्या मशीनला काही हॅम्पर होतो का? नो, दे आर डुईंग देअर टास्क ॲज देअर ओन. Okay, so if any of the machine get crashes, it will not affect overall performance of the system. Then coming to the speed, it gives enhanced performance through load distributing. Okay, so for example, जर माझ्याकडे 24 machines available असतील और राउंड फिगर आपण म्हणू 20 मशीन्स अवेलेबल असतील एखाद्या पर्टिक्युलर लॅबमध्ये तर डेफिनेटली आय विल बी गेटिंग गुड स्पीड. बट इफ इन केस सम 10 machines are not there in working condition, then at that time the speed will be a bit less. Why? Because each and every machine will be getting higher and higher load. Okay, so जेवढे जास्त मशीन्स माझ्या सिस्टीम मध्ये असतील तेवढं जास्तीत जास्त स्पीड किंवा ओव्हरऑल परफॉर्मन्स या ठिकाणी मला मिळेल. देन कमिंग टू द इन्क्रिमेंटल ग्रोथ. So computing power can be added in small increments. This leads to a modular expandability. So incremental growth, suppose I am having a lab of 20 machines and if for example I am adding 2 machines in my laboratory, so it will be possible. Okay, so overall performance, if I am adding 2 machines in my laboratory, will it affect to other machines performance? No, they will be working as their own. And if I am adding 2 machines, the overall performance after 22 machines that I will be getting is definitely more. Okay, so incremental growth is one of the advantages. Then again, data sharing. Definitely data sharing, how it allows many users to access a common database. Okay, so as we have seen the example of FTP server, so suppose for example all the required software for a particular subject or the notes which are shared on our FTP server. Okay, so many of the users can access that particular shared or common database, no matter the person is from COE or say for example pharmacy. Pharmacy means I'm saying this example as the if engineering student is there and he is accessing the data from pharmacy campus, then also it will be possible just by taking the IP address of that machine. Okay, that FTP address. So data sharing is possible in this case. Then comes resource sharing. So allows sharing of expensive peripherals like color printers, etc. So we can see that in each and every laboratory we are having one dot matrix printer. Okay, and for say for example like 2-3 laboratories we are having one laser printer. As we know the cost of these devices is very high. Okay, so we can have the facility of this kind of resources sharing. राईट, जेव्हा तुमचं सबमिशन असतं तेव्हा तुम्ही काय करता, प्रिंटर शेअरिंगमध्ये टाकला असेल तर नो मॅटर त्या प्रिंटर ज्या पर्टिक्युलर मशीनला कनेक्टेड असेल त्यानंच फक्त प्रिंटआउट काढायला पाहिजे असं काही नाही. you can go for sharing that printer and you can go for printing from your own location by just accessing that particular IP address. And this is what we are doing for our task, like in case of our library printer. Departmental library is having one printer, that is our laser printer, right? One is there in the HODK bin, but we are not going in the HODK bin for printing purpose. We are using the departmental library printer. So if suppose for example, if two, three members are there in a queue, but the printer is idle, then at that time by sharing that printer, you can go for printing out or print out the pages from your own location also. Okay. So in this way, you can go for resource sharing. Then communication, enhance human to human communication. For example, email, chat. So this kind of applications you can go for in case of distributed system. Then flexibility, spread the workload over the available machines. So whatever the workload is there, you can distribute it among different machines so that to achieve flexibility. Okay. So these are different advantages of distributed system. Um, right now we are using the application of Google Meet, right? So in which particular category it will be coming? It is a tightly coupled or loosely coupled, centralized or distributed. You can give your answers in chat window also. The example of Google Meet. Yes, anybody? Which type of example is this that we are using Google Meet? Hmm? Pratima Jadhav, are you there? See, this type of lecture should not be one-way communication. It should be two-way communication. And from your side, if you are not answering the questions, then it will be difficult. I already have given you the option for putting your answers in chat window also. Rushali, Rushali Swami. Not a single student want to answer for this. Hello. Afroz. Asawari. Communication. Vrushal is saying communication. I'm asking, we are using the Google Meet platform, okay? As we are using this particular platform right now for conducting the lecture. So, in which category it will be cover? It will be coming into like distributed or centralized, or tightly coupled or loosely coupled. Yes, definitely. Distributed system. Priyanka Kamble answering rightly. It is a distributed system. Why? Each and every person is sitting at their own location, right? But at the time of sharing data, you can share your screen. Okay. Suppose I want some data or some, say for example, presentation. Okay. So presentation, I will ask Priyanka to present your screen. So that at that time she will be presenting from her own location. Right now I am presenting my screen. Okay. But um, if I am presenting my screen, it will be or it is viewable or it is now shared with all of you who are present in the meeting. So this is the example of distributed system. You might have gone through the Zoom app also. Zoom app previously having maximum limit of participants up to 100, and I think the Google Meet is allowing up to say 500 something participants in it. Uh, if you have gone through some of the short-term training programs, STTPs or so, so there you have seen Google Meet or Zoom application. Zoom was previously having participants limit up to 100, but now it is increased. And if you share two or more um, such Zoom meetings and collaborate both with one, then you can have 500 plus participants in that meeting. So nowadays, day by day, the systems or such kind of softwares are gaining popularity because with online platform you will be able to um, contact or access as many number of participants as you can. Okay, before some days, I think. Um, 2 3 days ago, one session was there by our Vishwas Nangre Patil sir. Okay, so at that time, near about 900 participants were there in Zoom meeting. So this is now the availability or what we can say, good facility is given by all these platforms to us, we can say. Okay, so all these are coming under the distributed systems platform. So now we are going for the distributed computing system models. So different models are there under this particular environment. So in which the first is the mini computer model. So in this, as per the diagram, it is shown over here. Suppose this is the mini computer and having some of the terminals. So such many computers, number of mini computers you can connect by using such a communication network. So this kind of a model is called as a mini computer model. It is a simple extension, we can say, of centralized time sharing system. Uh, so as shown in this particular diagram, distributed computing system based on this model consists of a few mini computers. So they may be large supercomputers also. So they are interconnected by a communication network. Each mini computer usually has multiple users simultaneously logged onto it. So So no matter which particular machine is on, which particular machine is off, we are having that particular flexibility. But this several interactive terminals are connected to each mini computer over here. The network allows a user to access remote resources that are available on some machine other than the one onto which the user is currently logged in. Okay, but or we can say here the early ARPANET. You might have gone through this particular what you can say protocol, early ARPANET, which is the example of distributed computing system based on the mini computer model. Okay, so this is how the working of this mini computer model will be done, is done. Next is workstation model. So this is the structure for workstation model. So in this, again, communication network will be there and it will be connecting different workstations. Okay. So this is called as a workstation model. So as per this particular figure, distributed computing system based on this model has several workstations interconnected by a communication network. So for example, we can say that here one particular company's office, okay, MNCs are there and that office, uh, if we consider as an example here, so several workstations uh, scattered throughout the building or the campus, right? So if we go to Pune and at that or the for that particular location, if we go for Infosys campus, so it is divided into phase one, phase two, phase three. Okay. So phase one is working as one particular workstation. Phase two is another different workstation. Phase three is also, but all they are connected by using communication network over here. So you can take MNC's example for this particular figure. Then um, so it has been often found that in such an environment at any one time, suppose for example, especially at the night, a significant portion of the workstation are idle. So that means they are not being used. So it results in the waste of large amount of CPU time. So therefore, the idea of the workstation model is to interconnect all these workstations by the high-speed LAN so that idle workstation may be used to process jobs of users who are logged on onto other uh, workstations and do not have sufficient processing power at their own workstations to get their jobs processed efficiently, we can say. So suppose for example, if you are dealing with this particular workstation model and okay, so here suppose for example your workstation like present in Pune campus, one is there in say for example US campus is there, US United States it is there, then one is there in say for example Japan. Okay, so as per the timing zone, we will be here. We will not be working in the night time, but if we consider US time zone, they will be exactly opposite. Means if we are working in the daytime, for our if we consider our night time, there will be daytime for them. Okay, vice versa like that. Okay, so for this particular situation, if we are not working in the night time, so these people will find our site as a idle in the night time. Okay, म्हणजे त्यांना काय होईल की आपल्या साईडला त्यांनी जर एखादी रिक्वेस्ट आपल्याला डेटासाठी पाठवली रात्रीच्या 2 वाजता वगैरे, तर तेव्हा आपल्याकडून त्यांना काही रिप्लाय जाणार आहे का? नाही, कारण तो आपला वर्किंग टाइम नाही आहे त्यामुळे. ओके, सो दिस काइंड ऑफ प्रॉब्लेम मे बी देअर, बट the condition is that you have to so to get access to all these requests, no matter coming in the night or very late or so you have to keep your systems on at every moment of time. बरोबर आहे. जर रात्रीच्या 2 वाजता कुठला जरी एखादा कॉल येत असेल, एखाद्या सिस्टीमला कुठला जरी येत असेल, तर त्या सिस्टीमला मी कोणतरी पर्सन अलोकेट करणार, ठीक आहे. पण त्या केसमध्ये बाकीचे सगळे पण मशीन्स मला ऑन करून ठेवावे लागतील. कशासाठी? कारण जर मला किंवा आपण म्हणू शकतो की काही रिक्वेस्ट क्लायंट कडून जेव्हा येतात, मेल प्रोसेस वगैरे होतं, तर ते मेल प्रॉपरली आपल्याकडे एका म्हणजे त्यावेळेला आपल्याला काय करावं लागतं, आउटलुक वगैरे कन्फिगर करून ठेवावं. ते सगळं करत असताना तुम्हाला तुमचे मशीन्स हे पूर्णपणे ऑन ठेवावे लागतात. काही काही सिस्टीम्समध्ये तर तुम्हाला 24/7 तुमचे मशीन्स ऑनच ठेवावे लागतात, नो मॅटर यू आर ऑन हॉलिडे. ओके, तर त्या केसमध्ये त्या केसमध्ये आपल्याला काय करावं लागेल की या केसमध्ये आपल्याला सीपीयू टाइम जे आहे, म्हणजे अननेसेसरीली पॉवर वेस्टेजचा जो काही प्रॉब्लेम आहे, तो आपल्याला या केसमध्ये दिसू शकतो. ठीक आहे, जस्ट 1 मिनिट. Okay, if anybody is having any kind of a problem, they can post their queries on WhatsApp also, because when you are in a meet, you are not able to answer the call. Okay, I just now got call from PC, but I am not able to accept that particular call. The instruction is there for all others also. Okay, so this is nothing but our workstation model. So with this model, we can say that it is absolutely not so simple to implement. It might appear at a first sight as a simple one, but it is having some issues with it, and the issues could be the first one is, we can say that, how does the system find the idle workstation? So suppose you are here in India and your colleagues are there in US, UK or so. How they will find that your workstation is idle? So that will be a challenging task. Or for suppose, for example, here if we consider the workstation is present in just a van. Okay. Suppose, for example, I am in if we consider the location of Pandharpur only. Okay, so your location is there at our college campus. Then again another workstation is there near to the SC. Another workstation is there, say something at the location, say near to Lifeline Hospital also. Okay, so how I will recognize that the workstation near Lifeline Hospital is in idle condition? So that will be a difficult task. Then again, so this is one of the issues. Then second one is how is the process transferred from one workstation to get it executed on another workstation? So how this particular process execution will be done for two or more workstations? So that is also one of the challenging tasks. Then coming to the third one is, what happens to a remote process if user logs onto a workstation that was idle until now and was being used to execute a process of another workstation. So here in this case, uh, migration of the remote process back to the home workstation so that its execution can be continued there. So this can be possible. So this method is difficult to implement because it requires the system to support preemptive process migration facility, right? So the definition of preemptive process migration and its issues we are going to see in coming chapters also. So this is how the workstation model is working, but having some issues that we already have discussed. How you are going to find the idle workstation, how the process transferred from one workstation to another, and the third is what happens to a remote process if a user logs on to one particular workstation that was idle until now and was being used to execute a process of another workstation. So for this, we are having different algorithms also there that we are going to study in coming chapters. Then coming to the next model that is workstation server model. So here in this case, again the structure is somehow like the previous one, workstation model, but in addition to that, we are providing the mini computers used as a file server or a database server or a print server like that in this particular model. So the workstation model is a network of personal workstations, okay, each with its own disk and a local file system. In case of workstation model, they are having their own disk or local file system. So a workstation with its local disk is usually called as a diskful workstation, okay, and which is not having its own local disk, they are diskless workstations. So with this high-speed networks, diskless workstations have become more popular in network environments than in the diskful workstations. So making the workstation server model more popular and more useful in today's world. हॅलो. हॅलो. अबोली. अबोली, कनेक्शन कधी कट झालं होतं सांगू शकाल का? हॅलो. तेजस्विनी, somebody should answer. कोणीतरी बोला ना. माईक ऑन करा आणि एक जण सांगा कधी कनेक्शन इंटरप्ट झालं होतं मध्येच.
हॅलो मॅम. हॅलो.
हा बोला. हॅलो, हा बोला.
हा येतोय ना
तेजस्विनी,
आवाज?
आता येतोय.
हा
कनेक्शन मध्येच लॉस्ट झालं होतं का मगाशी?
हा 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 झाला असेल.
कुठल्या बीटला, म्हणजे पुढचा बीट लक्षात आला का? पुढचे 2-3 मॉडेल्स आपले झाले होते त्या केसमध्ये. हॅलो.
हॅलो.
हा.
हा मॅम, नेटचा प्रॉब्लेम मुळे मी आता जॉईन केलंय, होत नव्हतं.
नाही नाही, ऍक्च्युली माझंच इथे काहीतरी प्रॉब्लेम झाला होता बहुतेक. इथूनच
हा
लॉस्ट झालं कदाचित, असं वाटतंय.
हा हा, बरं बरं. आता येतोय आवाज व्यवस्थित.
ओके. वर्क स्टेशन सर्व्हर मॉडेल चालू होतं का तेव्हा?
एक मिनिट विचारावं लागेल. कारण माझ्या मोबाईलचा प्रॉब्लेम झाला ना थोडा, त्यामुळे मी आता जॉईन केले.
Okay, no problem. ओके, सो वर्कस्टेशन सर्व्हर मॉडेल चालू असताना मध्येच इंटरप्ट झालेला होता, राईट? ओके, नो इश्यूज. याचे जे लास्ट एक 2-3 बीट होते ते कव्हर करून घेते, कारण मॉडेल्स नंतर मी स्टॉपच करणार होते, पण आता अचानक मला कळलं की हे झालंय, कनेक्शन लॉसमुळे प्रॉब्लेम आला होता. सो इन जस्ट 10 minutes आय विल फिनिश ऑल द रिमेनिंग पॉईंट्स. वर्कस्टेशन सर्व्हर मॉडेल पर्यंत आपण पोहोचलो होतो. ओके, सो 10 मिनिटाचा गॅप पडला मध्येच. सॉरी फॉर दॅट. सो नाव या केसमध्ये आपण बघितलं होतं. सो विच एवर द डिफरंट वर्कस्टेशन आर प्रेझेंट, here with this we are providing the facility of mini computer which is working as a file server or the database server or print server. All these things are there in workstation model. So whenever एक एक्झाम्पल सांगितलं होतं मगाशी की सपोज फॉर एक्झाम्पल एक माझं फ्रेंड आहे, तो दुसऱ्या वर्कस्टेशनला आहे, से फॉर एक्झाम्पल US मध्ये आहे, and I am here in this workstation which is situated in, say for example, Pune. Okay, and this particular person is requesting the data in the night 2 AM. Okay, रात्री काहीतरी त्याने डेटा मागितला, तर त्यावेळेला माझं मशीन आयडल असणार आहे, त्यामुळे मी ती पर्टिक्युलर रिक्वेस्ट प्रोसेस करू शकणार नाही. ओके, जसं की आपण डिसएडव्हान्टेजेस ऑफ वर्कस्टेशन मॉडेल मागच्या मॉडेलमध्ये बघितलं की you will not be able to recognize which particular workstation is in idle condition. Okay, so तो ओव्हरकम करण्यासाठी आपण वर्कस्टेशन सर्व्हर मॉडेल यूज करत आहोत. इन दिस पर्टिक्युलर मॉडेल वी आर हॅव्हिंग these different file server, database servers, or all these things where I can put my data on that machine. So no matter at which particular moment of time the request will be coming from my user, at that time I will be able to fetch that request. जेव्हा कधीही रात्री वगैरे मला जर रिक्वेस्ट आली तर ती रिक्वेस्ट मी माझ्या साईडनं प्रोसेस करू शकेन. बरोबर आहे? So this is the working of workstation server model. Then we have processor pool model. So here in this case also we are having different terminals which are connected by using the communication network, and we are having a pool of processors. Okay, so जसा म्हणजे almost the same working as like our workstation server model. पण या ठिकाणी सुद्धा आपण काय करणार आहोत की सो या ठिकाणी आपण काय करणार आहोत की whenever the request will be coming, at that time we are going to process that particular request. So in this there is no concept of something called as a home machine. कुठलाही एखादा सर्व्हर किंवा असं काही नसणार आहे. That is, a user does not log on to a particular machine but to the system as a whole. Okay, so this is in contrast to other models in which each user has a home machine. म्हणजे जर बाकीचे आपण एक्झाम्पल बघितले, फॉर एक्झाम्पल वर्कस्टेशन मॉडेल असेल और मिनी कम्प्युटर मॉडेल असेल, in that case we are having something called as a home machine, but this is not the structure present in this particular processor pool. Okay, so as compared to the workstation server model, the processor pool model allows better utilization of the availability of processing power of a distributed computing system. So this is because in the processor pool model, the entire processing power of the system is available for use by the currently logged on users. So whichever machines that are there which are not idle or which are absolutely logged on, okay, so they are getting all the access to the data, whereas this is not true for the workstation model. This is not the condition in case of workstation server model. Okay. So this is how the working of processor pool model is there. And finally, we came to the hybrid model. Okay. So we have gone through the mini computer model, workstation server model, and processor pool model. These four models we have seen. So out of these four models, the workstation server model is mostly widely used model for building the distributed system. And this is because a large number of computer users only perform a simple interactive task such as editing the jobs or sending the emails or executing the small programs. Okay, so workstation server model is the ideal for such a simple usage. However, in a working environment has a group of users who often perform jobs of needing massive computations, the processor pool model is more attractive and suitable for such kind of a massive computations if they are there. So to combine the advantages of both the workstation server model and processor pool model, a hybrid model is used to build a distributed system. So hybrid, definitely it will be the combination of these two models like workstation server and processor pool model. Okay. So with this we are ending with the distributed computing system models. Okay, so for now we are having 29 people in our chat, or sorry, in this meeting. So with this point we will just stop here. But